This is clearly a VOD for you because no one is watching at this stage. My name's Chad. I am working on a 3D printed guitar that is on a lot of high-tech equipment, LEDs in it, some other electronic, somewhat robotic type things that are going to be built into the guitar. And what I want to do tonight is to just kind of step through the process of building out the PCB for the control panel that's got all the knobs and the screen. Got a couple different camera angles I want to test. So I think that's what I'm going to start with. That is my overhead view of my workstation. That's me. Right now I'm just making sure that my lighting works and that I'm not going to get 20 minutes into this and realize that you can't hear me or something. Okay, that is my studio, main view. And let's jump over to the other area. Hey, there we are. Okay, let's do an overhead. What we're looking at here are the components that we'll need to assemble the PCB for the control panel. Now, if you have been following my build so far, you'll know that I have a guitar that has a custom-built PCB, and that is going to run a bunch of LEDs, it's going to run motors, and it's going to also be controlled by this control panel here, which is, kind of a mess because I'm still working on wiring all this mess up. But what I need to do is replace all of this with a nice clean PCB that I got built from JLC PCB. They were kind enough to do that for me, which I will also be doing a proper video on. But for right now, I just want to get this thing together. Let's do it. So what I've got is a 240 by 240 TFT screen. This is the same thing that we saw on the other one, but it's just a new version. Essentially, this is just going to line up, assuming that I should say, this is all assuming that I designed it correctly, but this should line up and connect right about like this. The PCB has an encoder placement and 3 different buttons that I can use for various options. And then on the other side of it, you can see this is where, let's see if I can zoom in here a little further. This is where I'm going to have a header that goes out from here to the actual main board of the guitar. What I've got are some resistors to help with the LEDs, some diodes, which will do some fancy stuff that will theoretically allow me to help the light show up brighter when you tap it. That's the theory, at least. I've got this working on the live version, but so this is what we're trying to accomplish here. You can kind of see that this has light, and if I press down on the button, you can see it gets a little brighter. That's why I've got all these little components here. Other than that, it's really just a board that holds buttons and an encoder and a screen. So we've got a few other resistors that are going to help us with adding a little bit of voltage to each one of those buttons when it's pressed, and that's about it. So these should be the 10K resistors. Yeah, they are. I'm going to zoom in here a little bit just to get a better picture so it's not so hard to see these little components. It's 1K. Are these all 1Ks? So silly as it seems, even if I'm just working by myself, it makes more sense to really spend a little bit of time organizing these, because once I'm in the heat of assembling, I'm going to either forget what's what or lose track of things, and things will go all over the place. I am very good at that. So let's just spend the time to make this neat and ready to go. Also, I'm not super duper excited about the color choices here. These come in packs of like 10 each, and somehow I've misplaced like 80% of them, and these are the only colors that I have right now. At some point I might swap them out, but this will work just to get things running. Okay, so let's get these put away. Right now I'm doing all of the things that I would normally never do by myself, but now I'm being watched, so I gotta pretend like I'm organized. And this is how I know what's what. So what we're looking at is tiny, tiny little resistors, and I seriously doubt that I can get it on camera, but each one of them have a little tiny number, and that is not the value of the resistor or the measurement, but instead it is a number that corresponds to a code that you can derive the measurement from. So that makes it nice and difficult. So typically, and as a matter of fact, I probably can actually, I do have this guy right here, which is a hot plate. This is going to allow me to do some quick soldering, at least on one side. Obviously, I don't want to use this, heat up all the solder and components, and then flip it over, because if I do that, then, you know, that side will fry. So this side here has all of the small components on it. So this is probably our best candidate for doing that. And then we can come back around and manually solder the couple components on the other side. Sure, why not? Let's do that. Okay. We need some solder. So definitely don't want to put that on there just yet. Right now we're going to spend a little bit of time adding a little bit of solder paste to all of these contacts, placing the components, and then we can spend whatever necessary time doing some cleanup before I actually it's called reflowing it. Oh, you guys get to watch my shaky hand. Now, I could have gotten some kind of template for this. I actually have a template for one of my others, but this is just so small, it's not worth it. It's going to be also hilarious if I get this hooked up and find out that it does not work. Until you actually start assembling. Oh, that was messy. Until you start assembling it, it's just, there's no need to spend a bunch of time analyzing. You just gotta put one together and see how it goes. But it's very forgiving. So even though this may look messy, once the solder reflows, it all kind of locks into place, and then you can just do any final cleanup. There's also much better ways to do this. The story of my Band-Aid is unfortunately tied directly to this guitar. The other day, I was pulling off a guitar neck that I was 3D printing for another project that's coming up on the channel. When I did that, I got a little excited, and I was pulling off supports for it and using a knife when I really should have been using little wire cutter pliers that I usually use. And instead of slicing off the, there we go, slicing off the supports, I sliced off part of my finger. But did I go to the hospital? Nope. That's what super glue's for. Don't do as I do. Do as I say. Go to the hospital if you cut yourself. Better yet, don't cut yourself. I know, it looks absolutely dreadful. It doesn't matter. You'll see. That's a little better. Maybe I should have been doing it like that since the beginning. As a matter of fact, I'm spending way more time on this than I typically would. I would usually just lather it on there, kind of do a little quick cleanup, and then let the heat do the rest of the work. Okay. Okay, it is not on, by the way. That's important. Now, I'm trusting that my former self was smart enough to really think through how this is put together. So We're hoping that I was correct, but I don't know. We've got some signals going from the LED buttons, the actual button push part, to the outboard microcontroller. But then you've got to add another signal for the LED. And if you just add a power signal to it, then all you're getting is just one solid light. Well, since I want to have it light up a little more when you press it, I have to basically branch off the voltage from the input source of the voltage and then pass it through a another resistor to drop it quite a bit, just enough to allow me to then accept just a little bit higher voltage when that button is pressed, using a diode to make sure I don't feed that power backwards, and thus that gives me a slightly brighter button color than it would have been otherwise. That's the theory. Works on my manually soldered board, but man, that thing is messy. When you are first assembling, or when you're first designing it, I should say, you're really cognizant of how everything is laid out and making sure all of the components are oriented properly. But when you're assembling, you're not really thinking about the the route of the traces and the overall signal path. So it's much more just about following the instructions on the board, which is why it's so important to have a board well documented on there. You'll see a lot of circuit boards or PCBs that are that just have like R1 or R2 or something like that on there for each component. I don't like to do that, and definitely you can see that in a lot of my other circuit boards that I've built, that some of them that are on here. You'll see that I've got very specific and detailed notes on every single component, because I would much rather be able to just assemble and not think about it than have to try to go back to some kind of menu or not rather menu, a diagram to figure out what I was even doing. Because that's when you make mistakes, when you lose your frame of reference. Couple more resistors here, and then we can get it all connected here before, or get it fired. Before I actually do that though, what I think I'm going to do is see if I can pull up the diagram to show you how this turned into, this went from the diagram to turning into the actual PCB that we're sitting in front of right now. Okay, we're going to go over to the main computer for just a minute. And I'm going to pull up a diagram to actually show you what this thing looks like in the design phase. This is something called EasyEDA. This is just basically a diagramming software that's online. It's free to use. It's pretty intuitive. I would say it feels like there are probably much more complex and capable tools out there, like KiCad and a couple others that I've seen that are regularly used. In my opinion, what little I've tried with those, it's fine. If you use something like this, you can usually get anything you want to get done. And really, just like with any tool, the more that you are focused on what you're creating and the less you're focused on how to learn something, typically the better quality the end result will be. Anyway, what we're looking at here is just all the components that we saw on that PCB. Actually, let me grab a copy of it. I've got a couple copies. All right, so we'll see here, this is the PCB, and each of the components on the screen represents one of those little items that have the lines around them. So once we have this all designed out and we've got everything routed, what we hope is proper, then we can go over and look at the actual layout, how we laid it out on the board. And this is what that looks like. So this, what we're looking at here is a mixture of the top and bottom. So let's hide the bottom first. Okay, the big thing that you want to kind of focus on here is the SMD components, which are the resistors, diodes, things like that, that we're working on soldering right now. And then you got through-hole components, which basically means that there's a pin or a little piece of metal that goes through each one of these holes on the other components. So these guys right here, these are the buttons. And then over here, you've got the encoder footprint is what it's called. Now flipped on the other side, I have the actual spot for the encoder where you can see that's all the pads on there, the screen over here, and then the buttons. It's pretty much that simple. I've got the header here, but then when I combine all of the routing, basically each one of these components needs to get routed in a particular way, and it takes a lot of time to find the best routing. You can do some kind of automated routing and stuff, but it usually turns out really messy and or sometimes doesn't work at all, especially if you're working with a lot of components in a small space. I chose a 2-layer board in this situation as opposed to something like a 4-layer board, which you can get to make things a little easier to route, but I wanted to keep these not only cheap, but as basic as possible, since I wasn't trying to route a lot of complex components. It's more of just fitting a lot of stuff in a small space. So just trying to keep it as easy as possible. So that is the layout of what we're getting ready to solder. So let's jump back over there. Hey man, what's up? KiCad. So you said, question, KiCad takes 5 gigabytes. Do you recommend switching to EZA? Man, EasyEDA is so, it's so easy in comparison to KiCad. I would not even touch that unless you have a reason to have that in your workflow. You can just log into EasyEDA from any computer. I know there are some web components for KiCad, but it's easy, it works, and there's a big community around it. So that's what I would suggest. Also, there is a lot of overlap in the amount of skills that you use in both of the softwares. So let's get this started. I am still getting used to my live setup, guys, so bear with me here. And there we go. Okay, let's back out just a little bit here. Okay, let's just do a quick sanity check. Actually, let's go back in here. So what I need to make sure is that I didn't miss any little tiny components. I've got 3 diodes, 3 1K resistors, 3 10K resistors, and all of this is just for controlling the lighting for the buttons. So don't be thinking that there's anything really complex going on there. There's not really much else that I can do with a heat plate because this is going to reflow the solder, and when that happens, then I can just kind of flip it around and finish out all of the through holes. Yeah, man, no problem. Okay, so this thing always makes me nervous because I have used it a couple times. First time, obviously, I burned some plastic on it, but let's give it a go. I am not a trained electronics engineer, by the way. This is stuff that I picked up just because I enjoy it. I started with some robotic stuff, and I just kept at it until I kind of got the hang of it, and here we are. So we are probably a minute or so from being able to put this on. This has to get up usually, I think about 220 or 230 or something like that. And it's pretty safe to drop it on here, but it doesn't take a whole lot of heat to reflow. Come on. In the meantime, let's move this over here to just let it heat up and talk about what we've got going on here. These are all the things that I don't get a chance to talk about when I'm doing the really condensed videos. I spend a whole lot of time trying to cut those down as much as possible. So let's take a little closer at what we're replacing here. Really, if you look at it, I've just got this little encoder here, and these all route to this, and the buttons all route to this piece, or this circuit board here, that is just an absolute train wreck. But that's the only way I could really fit it all on there and make the modifications slowly as I needed to make sure that, you know, I was able to get the lighting to work. And once I did get that working, basically I just got this, I built a little harness that I was able to route everything properly to then just get plugged right into the board here. So essentially what I'm going to have to do is, once I get all this reflow stuff done and the new control panel done, I'm going to be able to, I'm going to have to build another one of these harnesses and then get it plugged in. So the reality is that while I might be able to get everything connected today, I probably won't get the harness done. So I can definitely smell it. It smells like it's about ready. It's at about 196. We'll see if that'll work. Okay, I've burned myself enough times to know to take great care with a hot plate. I've also dropped these things and ruined my reflow. Okay, so here we go. Should not take long at all. And I see a little bit of smoke. Now, if I was doing more, I would actually, I do have a little suction fan that I would pull the fumes out, but there's just not that much. You know what? Actually, I'll go ahead and throw it on. Okay, so as you can see, all that mess is getting itself cleaned up, and these are pulling themselves into place. That's why I love doing this reflow instead of manually soldering these small components. There's just no need to spend all that time. Okay, and that's pretty much it. These components are as done as they're gonna get. Now I gotta get it off here without ruining it. Yeah. And get this thing out of here in a place that's not gonna set on fire. There we go. From here, I could go ahead and start putting the buttons on, but I think I'm going to do some continuity tests. So let's do that. Where did it go? How you guys doing? Oh man, how's it going? What time is it here? It is 10:53 p.m. Pacific. Do you do any DSP with that Pico? No, not yet. Only because I haven't gotten to that stage. That is definitely on the list of to-dos. Okay, this should be cool enough to hold, and it is. Yeah, so now I think what I'm going to do is spend some time just making sure that the connections that I can test all make sense before I put any power through this thing. And I will put some power through it to make sure that it works. I swear I'll get better at this, guys. I'm new to this live streaming stuff. Okay. Okay, so we want to make sure we don't have any funniness going on with the diodes. Immediately, there's some funniness. No, we're good. Okay. Good. Good. Sure we're not going in the other direction too much. Oh, come on. You just woke up. Oh, yeah. Time zones are a mess. I do work where I've got to constantly deal with people in different time zones, and it's a challenge. What exam? So you're preparing for an exam? Ugh, that's not a fun start to the morning. Oh no, it's fine if you can't stay long. I appreciate you guys just popping in. All right, that's good. I think we're good. Let's see. We're looking for 1K here. Yep. Come on. Okay. It is really hard to get a read on these little tiny ones. I need to get one of those little sets of SMD probes. I don't know if you've seen those or not, but they are, you can buy them on places like AliExpress, and they are the coolest thing. They're basically, aside from just not doing voltage, they're little multimeters that can do all this kind of stuff in just a, a probe tweezer kind of scenario where you just go plonk and it gives you what you need instead of this mess. You're doing an oral exam for a course called Probabilistic Sensor Fusion. Boring stuff. What you're doing is more fun. Yeah, I'm not gonna lie, that does not make any sense to me. This is the problem. You spend your time learning foundations that I should probably be learning, but it is what it is. Well, good luck, man. So yeah, I mean, all of the resistors look good. Those look good. Let's just throw some power through it to make sure that there's nothing funny going on. And the only thing that I don't have live stream set up that I will hopefully get soon is a mobile camera, so I can actually bring you along with me here. But basically, if I can pull it out here, I've got this power supply. It's a basically I think it's a 10 amp dialable power supply that will hopefully, I'm just going to keep it low voltage so I don't do anything funny, and I just want to make sure that it's not I don't have anything crossed or mis routed. So the way that I've got the PCB set up, I did not label the header or the screen header, and that's coming back to bite me because I do like to be able to just see what goes to what here to be able to quickly test. I'll figure it out though. You can kind of see, I don't know if you can see this or not, but when you are working with a PCB that usually, especially when it's two-sided, you can really see where the traces are, so that helps a lot with that kind of stuff. Okay, so power. I think this is, yeah, so this is going to be power and this is going to be ground, I think. And yes, I'm using little jumper cables up. Something's going on there. See, this is why we test. Well, you know what? That might both be power. That's my fault. There's nothing wrong there. Oh, then which one is ground? Oh, that's because that one's ground. Pay attention, Chad. Jeez. Yep, okay, so voltage is showing stable. I know you can't see that, but that's looking good. I want to make sure I'm getting the same thing over here. So basically, just to clarify, what I'm doing is, while you're putting all this together on a diagram, it's easy to see how everything's routed, but once you actually wire it up on the actual diagram, you know, where you place everything on the boards, it's kind of hard to always make sure that you have everything cleanly routed and none of the traces are touching or anything like that. So yeah, you said I've accidentally printed PCBs without any labels because I put them on the wrong layer. That was a good learning moment. That's interesting. I've done something similar like that, but with the screen print for what am I thinking? The template. So I put the template parts on the wrong one, and they called me up and they were not too happy about it because it messed up the first board that I ever printed. So learning experience. I can tell that they deal with this kind of stuff a lot because of how many people are getting into PCB manufacturing that are just, you know, hobbyists and stuff. So it wasn't that big of a deal, but I know what you're saying. It's kind of a bummer when you get it all the way from across the world and suddenly you have to get it reprinted. All right, so we want to make sure that once we get these plugged in, that we've got some power going to the appropriate power points, and then we're good to actually put an LED on there. We're gonna let that guy sit there for a minute. Hopefully it won't slip out. Don't slip out. Ah, and it slipped. Let's go this way. Okay, so we'll just borrow the ground from one of these. I think this is ground. Funny thing is I do actually have a PCB holder, but I'm an idiot and I'm not using it right now for some reason. Where's some power? There we go. There we go. All right, man. You gotta go. All right, take care. Thank you again for stopping out. I will hopefully have a proper video up here pretty soon with some of the latest. Okay, so that's good. We're getting power. If we get power to one, we get power to them all, so I'm pretty excited about that. Let's just check one or two other quick little things. Let's go there. And we'll grab this. Well, I was expecting power to that. Am I missing something? No, that's voltage. There we go. Okay, yeah, no, I think we're good. I think I am going to wire up one of the buttons here. You guys, you gotta help me out here. I don't know. Red, green, yellow. I know it's a stop sign. what order do I put these in? Because obviously they don't mean anything right now. So if the PCB is going to be facing this way, I'm trying to think of how it's going to be oriented for you guys. So we've got here, we got the screen right here. And I don't know. So we've got our little encoder guy right here. Was this going to go green, yellow, red? Yeah, probably. Ugh, I do not like these colors. What sucks is that on the bad board that I've got on the guitar right now, the colors are great. I've got a blue, a clear, and a blue. Also, I'm just not a fan of these buttons really overall, but I spent a lot of time trying to look into some button options, and these are the only ones that I really, that really did what I wanted them to do and had any kind of decent styling. All the other ones were just really clunky and ugly. And when you're talking about the couple pieces that actually stick out of the circuit board, you want them to be a little bit aesthetically pleasing. Oh, now I have to determine which way do these go. Oh boy. Okay, how do we do that before I go messing this up? So I noticed that these all have little colors pointing. I think that I can use mine as a reference to figure that out. Nope, don't want to wreck the screen. Okay, so in mine, I've got the colors going that direction. Where does that route to? Looks like that the color is the ground. So there we go. I'm sitting here preaching about how careful I am about labeling stuff, and then I don't even label the direction for the buttons. Smarty. So, well, no. Also, the footprint of these buttons, this is going to be interesting if this even fits, because I had to customize the footprint. It was not exact. The problem with the designer software is that they're only as accurate as the models that you get, and while a lot of them are, obviously built off of real world things, some of them are just community based, and you try to find the best one you can. But if they don't have one of those models available, mass produced by someone like, or properly produced by someone like JLC, then you have to either build your own or go with a community one. So I think I took a community one and just tweaked it a little bit. I mean, the footprint kind of works. So I can see that there is just an ever so slight trace going from, come on, focus. There's an ever so slight trace going from this resistor to this pin right here. So that tells me that that is the positive and this is the negative. And if the negative is the colored side, then that should be right. So we're pushing this on. Oh, that one bent. This particular unit I was testing with, and that's why the pins are a little bent. Okay, let's try it again. I mean, that works, except for the fact that the one pin has a little bit of residual solder from when I was testing. All right, you guys are gonna laugh. I've been, I've got steel wool. I've always shut up, you're gonna laugh. I've always preferred doing this because you're not only cleaning the metal off, but also it gives you an opportunity to just kind of use the paper towel to get it a little bit shinier. In my experience, if you're using steel wool, then it kind of leaves some stuff behind, but that's just me. Okay, here we go. Oh, come on. It jumped. See, this wouldn't be a problem at all if I didn't have that residual solder on there. There we go. Oh, nope. Okay, let's try that again. What I'm doing right now, where I'm holding the soldering iron while I'm doing things, has bit me more times than I can even count by accidentally touching something or myself. I would not recommend. All right, so let's get this blob of solder out of here. Come on. Behave. There we go. All right, let's try that again. There we go. Cool. All right, that looks good. And oh my gosh, it actually lined up. Look how clean that is. Wow. I was not expecting that. You can see the little notches in there. I mean, they might be off by like 1/4 of a millimeter. Something, you know, like maybe 1/2 a millimeter, but that's close enough for me. It works, and then I drop it. It works. So I'm gonna lock that one down, and the other ones will go really quick. I know I'm dragging things out slowly here, but I'm just kind of feeling it out. This isn't something you really rush the first time around. Once you get comfortable with the design and you know everything's working, you could just crank this stuff out quick. I need some air cleanup here. This is just a little 3D printed device that I partially came up with myself, and then also used an online model that someone posted. It's basically just a fan with some filters on the end, and then this little snake guy right here allows me to position it to some extent. What I find with 3D printed tools is that they work for a little bit and they work kind of in a isolated scenario, but the moment you need them to perform in any way that's at any level of professionalism, they kind of fall flat. And I hate to be a generalist like that, but overall, I mean, that seems to be the experience that I've had for everything 3D printed. It's fun. I love it. I do it constantly, but would I actually rely on that stuff in the real world? No, probably not. So I'm running into a little problem here because I've got some kind of a marking on the metal for this one, but I think the paint wore off. Well, I guess only one way to figure this out is to run a tiny bit of power through it and figure it out. We're just gonna run like a 1.5 volts through it or something. So if I'm correct, then that little red dot means that that's the negative, oddly enough. It might not be enough voltage. Basically, I'm just running a small amount of voltage because I don't want to burn out the LED. Let's crank it up just a little bit. Let's do 2.1 volts. Oh, there you go. So that, I was right. So that little red notch is an indication that that is the negative, which makes no sense, but whatever. And we have learned that the negative is right here. You know what? Before we do that, maybe we should test this. We've got all of the LEDs. Oh man, I don't want to do the test this early. I don't want to be disappointed if I come to find out that I wired up something wrong. But I guess we should. I'm going to run absolute bare minimum amount of voltage through this. And what I expect to happen is, if this is wired right, it'll immediately light up, and then if I tap the button down, it should light up brighter. That's the theory. Wish me luck. Okay. So okay, so there we go. So negative. Oh, I think I see something. Okay, so, and that's fine because I've got it low voltage right now. You probably can't see that. Let me raise it just a little bit. There we go. Okay, so we've got some voltage, and at least that's right. So, hey, that's something. Now, if I press this button and that gets brighter, I did my job right. If it doesn't, I mean, this might still work, but, you know, I mean, there's a flaw in the design somewhere. Cross your fingers. Here we go. Oh. Well, let me throw a little more voltage into it because that seems to be a bit dark to tell. I'm not seeing the change. It's not out of the question, though, that the resistor that I'm using was purposely a little bit too strong to where it's not giving enough extra voltage. That's a bummer, though. I was hoping that it would just work. Oh well. Okay, so one thing we can do is check the voltage at the LED to see if that changes even a small amount. And if it does, it quite likely is just that resistor that needs to be changed out. Maybe that 1K needs to be something like a 300R or something. 2.192, and as I take the button off, is it less voltage? No, it's not. Considering how long I spent diagramming this out, I have trouble believing that I did it wrong. So I think I'm going to have to come back to what's going on with that voltage increase there, because really, I mean, that was, even though it's a little tricky, it's not that complicated of a circuit. All right, well, whatever. Let's get the other ones soldered up, and then I'll diagnose that at a later point. At least if we can get the buttons working, that's something. And this should go much, much quicker now. Get in there. I have a feeling that once I get this done, this is going to be a little anticlimactic because even though it's really cool that I'm able to get all this together and test to make sure that everything is at least routing properly, the process to get this all connected to the main board, that's a whole thing. So we're just having some fun tonight. We're not looking to break major ground. Actually, I might even go as far as to divert if I keep going a little bit later and do some playing around with the actual guitar, goofing around with the design, maybe even show a little bit of the other one that I'm working on. You know what? Just for fun, let me dig this out, because yes, I do actually have one of these things, and I just, for some reason, keep not using it. In case you haven't noticed, I have severe ADHD. And you can call it a superpower or you can call it a detriment. But for me, it's a little bit of both depending on the day and what's going on. I can definitely go toe to toe with the best of them as far as how much work I can get done in a given day. But as far as keeping on track that whole time, it's sometimes a little more challenging, but it keeps it interesting if nothing else. Ugh. Let's get a little bit of clean air in here. And I'm sorry about the sound, guys. I know that can get a little annoying, but I'll try to keep it short. So, in case you have not done a whole lot of soldering, what I'm doing is, and this I'm sure is rudimentary for some watching, whether it be now or on VOD, you never want to solder, you never want to touch the tip of the solder directly to the solder roll or the solder coming out of the roll. You want to touch it to the component that you are soldering and then let that suck in the solder, because that's how you create a solid mechanical bond. If you don't do that, you get what's called a cold solder joint, and that basically means that it's not really bonded properly on both sides and it will crack. Okay, those are good. Where? Oh no! I've got one that wiggled its way out when I was putting it in there. Not a big deal, but in there. Just got for some reason they built these buttons, and they're very common buttons, but they build them in such a way that these side pins are just so thin and flexible, which is good right now because that means I don't have to take it all off, but also they just bend on a whim when you're putting them all together, and you don't even know that they're bent until after you get it all assembled. I guess unless you actually have eyeballs, which apparently I don't. Don't break, don't break, don't break. Yeah, got him. Oh, same thing with this guy. I see that. Might as well deal with this now. I thought I had those sticking out. Oh well. Come on, bend. Oh man, I know I'm gonna get this all together and that one is gonna break right there because it's been bent too far now. Come on. Just twist a little further. Okay, I've got it right there. I just need to actually get it fed through now. You can do it. You can do it. Yeah. Okay. That'll do. If I wasn't talking my head off, then just to be clear, I would probably have this done in 1/4 of the time, if that even, but I'm just taking my time. Whew. Who designed this? Jeez. Get off there. That's a joke. Me, I designed it. A pin all the way out there on the edge like that. I don't know why I put these unnecessary limitations on myself as far as the size of it. I could have made this thing easily 20 or 30 millimeters longer and save myself some headache, but whatever. It's nice when things are nice and compact. Okay, so, you know, I could use the reflow, the hot plate, to do this, but meh. Let's just do it by hand. I am going to use the solder paste though instead. I think that'll make it a little easier. Oh, shoot, I didn't even verify that the footprint lined up. I probably should do that. There's this other method of verifying where you put your, or you print out the entire PCB layout on a piece of paper and then you lay down the components and make sure they fit. And that's a smart thing to do. And for some reason, I forget to do that every time before sending it in. I'm usually on some kind of a deadline when I'm putting this stuff together because I'm working with someone like JLC or something. So I'm not really thinking clearly and thinking efficiently, or I should say thinking, thinking like in a, what am I trying to say? Thinking in a thoughtful way. It's the only way I can think to say it. So as I'm sitting here trying to talk, I'm realizing that I've got these little nubs here that were causing it to not sit down, which is fine. I'm sure that helps hold it in place, and I probably should have designed that into the PCB, but I didn't, so off they go. Oh shoot, you probably couldn't even see that. I didn't realize I had it zoomed in so much. So basically there was just two little nubs guys right there that I had to chop off. I mean, the footprint's fine. I think that those nubs would have made a big difference. All right, I'm gonna do the awful thing that you're not supposed to do by pulling this off to look and see how it's looking. I think I need more solder on there. I'm not happy with this right here. There's a lot of overlap between those, even though the solder does get pulled into the pads and it will almost certainly get rid of any connection right there. When you've got something that, you know, has got so much surface area underneath it, I'm always just a little concerned that it works itself up in there and maybe gets connected somewhere under here, because I think this is metal. So, and I don't want to have a connection under there and not even realize it. All right, man. I appreciate you stopping out. Take care. Hopefully I'll have something else for you guys to check out here pretty soon that's a little more structured. Okay. Now, the question is, do I use a heat gun? Do I use the solder iron? Let's just try a heat gun, just for the fun of it. I am really overcomplicating this. I don't need a heat gun, but whatever. It essentially operates very similar to a reflow hot plate, only from above instead of below. it can be a little concerning doing something like this if you've got a bunch of plastic parts all around it. So I am definitely watching those buttons to make sure that they're not behaving like I'm burning them up. I think it's fine. See, the problem with this, as opposed to the reflow method with a hot plate, is that if you do it all at once, the component will literally slide itself into exactly the perfect place in most situations. And unfortunately, if you're using a heat gun or just a soldering iron, and you're doing one at a time, the whole part, once it gets locked into one place, it's not going to move. But I mean, that looks done. Ouch, that was hot. I know you guys probably live for those moments. Don't touch it. I mean, that's pretty much done. I just need to get the headers on there and can actually start assembling the wiring harness for it. Let's see if there's anything else that needs done. Nope, looks good. I think what I'm going to do next is probably work out what's going on with the voltage spike that's supposed to happen when you press the buttons, why that's not working, and then get the header on there, and then I'll worry about the harness. But I'll probably go ahead and wrap it for the night because I didn't want to spend all night streaming. I just wanted to give you guys a little cool preview of this before I actually create a proper video on my channel about these new components for the guitar. So I appreciate you guys coming out, and be on the lookout for some update videos. In the meantime, if you've got any questions or anything like that, feel free to follow up in the comments of the replay on this video, and I'm happy to have a chat with you guys. All right, take care. I will talk to you soon. Maybe if I'm able to end the stream. Take care, guys.